Imagine an object in deep space that operates in complete reverse. Instead of pulling everything inward, it aggressively ejects matter, light, and energy into the void. It possesses an invisible, impenetrable barrier that absolutely nothing can ever cross. This intensely strange, erupting object is known as a white hole. To understand it, we look at this cross-section of its famous sibling, the black hole. When a massive star dying, its core collapses under its own immense weight, creating a singularity with gravity so intense that it forms an event horizon, a boundary that traps everything, including light. Black holes are proven cosmic traps that anchor modern astrophysics. White holes stand at the opposite extreme, representing a terrifying theoretical mirror image. The origin of this mirror image lies in Albert Einstein's equations of general relativity. When physicists solve these equations, they find that the mathematics governing gravity work flawlessly in both directions. The math perfectly balances the inward crush of a black hole with the outward explosion of a white hole. Yet, this mathematical symmetry exists independently of reality. While black holes are mapped across the galaxy, zero physical observation weighs down the white hole side. Which forces us to ask, does the universe actually build these symmetrical objects, or do white holes exist purely as phantoms on paper? Look at this side-by-side comparison. On the left, the black hole pulls matter relentlessly inward. On the right, the white hole relentlessly pushes matter away, permanently preventing anything from entering its core. This exact symmetry comes from a concept called the maximally extended Schwarzschild solution. It is a mathematical model that stretches the geometry of a black hole to its absolute logical extreme, creating a timeline where the black hole's past becomes a white hole. This grid illustrates how the math connects them. It suggests the bottom of a black hole links directly to a white hole via an Einstein-Rosen bridge, a tunnel through spacetime, commonly known as a wormhole. However, these traversable wormholes are entirely hypothetical. Modern astronomy has never observed a single one. The math describes a flawless, eternal geometric system, but the messy, chaotic reality of physical space strongly suggests that such mathematical perfection cannot form naturally. Despite the skepticism, scientists have mapped out exactly where white holes might hide. The first leading hypothesis suggests they could have popped into existence for a fraction of a second, immediately following the Big Bang, driven by the extreme density of the early universe. A second hypothesis relies on quantum gravity. It proposes that at the subatomic level, the fabric of space might undergo highly theoretical fluctuations that temporarily spawn microscopic white holes. This timeline visualizes a third idea. As black holes age, they slowly leak energy, a process called Hawking radiation. Some theoretical models propose that the final, explosive stage of a dying, evaporating black hole is a sudden transformation into a white hole. Astronomers have actively searched for physical evidence to match these ideas. When telescopes detect energetic events, like intense flashes of radiation known as gamma-ray bursts, some researchers speculate they might be witnessing a white hole eruption. But speculation is where it stops. Decades of scanning the cosmos have yielded zero convincing observational evidence. The search remains empty because the physics of our universe heavily favor entropy and decay. A white hole would be wildly unstable, collapsing almost instantly. The math writes an elegant equation, but the cosmos refuses to build it. The scientific verdict is clear. Based on current established science, there is absolutely no proof that white holes exist. Yet, the lack of physical proof does not erase their value. Theoretical physicists rely on white holes to test the boundaries of their equations. By studying an object that flawlessly reverses gravity, scientists can isolate exactly where relativity clashes with quantum mechanics. It forces them to rethink how spacetime operates at a fundamental level in the hunt for a unifying theory of physics. White holes serve as extreme theoretical stress tests. They expose the absolute limits of human knowledge, highlighting the exact point where our equations break down. We are left to wonder if the universe still hides impossible phenomena just beyond the reach of our current telescopes. Or perhaps white holes will forever remain one of physics' most beautiful ideas, a perfect mirror that nature simply chose not to create. If you want to keep exploring space, cosmology, and futuristic science with us, hit that subscribe button for more documentaries. Because the greatest mysteries of the universe almost always lie exactly where human imagination collides with cosmic reality.